So we are starting with overall heat transfer coefficient. Okay. A heat exchanger typically involves two flowing fluids separated by a solid wall. Okay. So that is why we have the mechanism of uh, normally in between convection and conduction. Okay, for radiation, normally we will associate that with the convective heat transfer coefficient lah. Okay, or R combined lah, kan, R combined. Okay, macam yang you kira itulah. Okay, so sometimes for force convection, radiation is very small part. Okay, so what you have is basically the convection in ni, the convection dekat sini, dekat luar ni. Okay, ni kat luar ni, and also the convection dekat dalam ni. Okay, dekat luar tu kita panggil annulus lah. Okay, and inside we call it tube. Okay, luar ni external kita panggil shell lah. Okay, and in between, of course, because you have some sort of pipe punya thickness, so you have wall conduction. Okay, conduction through the wall. Okay, so that would be the mechanism involved in the heat exchanger. Okay, start from convection outside, convection inside, and also the conduction in between. Okay, and radiation is subjected to convection lah. Okay, sama ada kat luar atau kat dalam, both ada chances untuk ada radiation. Okay, okay, if we are to express the heat related to this system, okay, whereby you have this general equation UAS delta T, okay, is equals to delta T over R. Okay, hopefully you still remember it's a concept of driving force over resistance, right? So the F over R. Okay, and when you try to equate this equation with all other equation, okay, so this one is for the overall equation, this one is for inside, this one is for outside, right? So when you equate this, so you can cancel out delta T, so you can express this relationship in between R and U. Okay, so 1 over UAS is basically R. Okay, it's sama lah. Okay, so for overall, okay, overall heat transfer coefficient, okay, or for overall resistance, okay, you might find that it is 1 over HIAI plus R1, which is conduction. Okay, this one is because of a cylinder. Okay, this one is wall for cylinder in tubing cylinder ni. Okay, tubing kat dalam ni. Okay, because dia ada thickness kan. Okay, and 1 over H naught A naught. Okay, and if, okay, the punya wall thickness of the tube is small, okay, meaning that the I, okay, R naught and RI is the same, most ni lah, more or less the same lah. Okay, so it is as good as thickness is 0 lah. Okay, it's very small and the thermal conductivity of the tube material is high. Okay, then thermal conductivity rate is very high, so there will be a significant heat transfer lah, in terms of conduction heat transfer. So R wall become 0. Okay, because of this is very high value kan. Okay, so this one jadi kecil je. Okay, so AS, A naught and AI is the same. Okay, so bila A naught AI is the same, you can cancel out all. Okay, semua dia boleh cancel out A ni because the value is sama. So in the end, dia punya sebutan dia is being reduced to only this one. Okay, so R ni dah tak ada lah, because it's kosong, dia agak kosong ya. So it live with the HI and H naught punya part saja. Okay. As U. Okay. U. But it all depends on the condition lah. Okay. If this is only applicable if the wall thickness is small. Okay. And in um, they will tell you in the question lah, if this would be the scenario. Okay. The question will state the wall can be assumed, or the R wall can be assumed 0, ataupun the wall thickness is very small, or the wall thickness is basically close to 0, for example. Okay, so then you can assume this as this equation. Assume the process as this equation. Okay. So please be very careful. Okay. And we will have another term lah dekat U ni nanti bila you have fouling. Okay. So this one is basically from Chengat and Gajah, okay, to state that you need some sort of conduction principle like itulah. We have convection. This one is conduction. This one convection once again. Okay, and we will not really care about the outside ni, external ni. Sepatutnya boleh juga kalau kata nak pertimbangkan external convection juga, external daripada pipe ni kan, tapi kita tak timbangkan lah normally. Okay. Alright, we move on to the first example. Okay. This is quite dia punya soalan dia pendek, tak adalah pendek, not really short the question, but the solution is quite lengthy juga. Okay. Although the question seems quite short, the information pun tak banyak sebenarnya. Okay, you have to be very careful with this type of question. Hot oil is to be cooled in a double tube ataupun double pipe lah. Okay, counter flow heat exchange, counter flow. Okay, so the copper inner tubes have a diameter of 2 cm and negligible thickness. Nampak tu? Negligible thickness. Okay. So maknanya inner and outer diameter is 2 cm lah. The inner diameter of the outer tube is 3 cm. So ni dah bertunjuk dah ni. 2 cm, 3 cm. So there will be no R wall. Water flows through the tube at 0.5 kg per second. Ni dah beritahu kat sini. And the oil through the shell at a rate of 0.8 kg per second. Okay. So we know that the cold water is inside the tube, whereby hot oil is in the shell ataupun in the outer cylinder. Okay, taking the average temperature of the water and the oil to be 45 degrees C and 80 degrees C respectively. Okay, kita tahu dah dalam mengeluar ni is basically adalah 45 and 80. So respectively determine the overall heat transfer coefficient at this heat exchanger. So yang ini sebenarnya, okay, jangan risau you will not because of the question is about overall heat transfer coefficient, so we will not have any calculation on Q lah. So basically, because we want to determine HI and H naught, okay, so you don't have to bother on the temperature itself. Okay. The fluid properties are evaluated at the film temperature or average temperature. Okay, so bermaksud you pergi balik dekat ni, in this question, okay, you kena tahu because you are talking about H, right? So bila you are talking about H, basically in convection. There will be no conduction in this question because there is a very significant statement just now, negligible thickness. Okay, meaning that R wall is 0. So this would be the only formula for U. Okay, so in order for us to determine Hi and H naught, we need to basically assess the NU. Okay, NU, whereby NU will be basically depends on the Reynolds number. Okay, because we want to know what is the flow regime. Okay, whether it is apa namanya, laminar or turbulent. Okay, and also um, entrance region lah. Tapi kadang-kadang entrance region ni tak diperlukan lah. Normally this two region ni lah, flow regime. Okay, then it will correspond to what type of NU punya equation yang you nak guna. Okay, so in order for you to get this Reynolds number, okay, Reynolds number for cylinder ni is basically V. V ni is velocity ya, Vd over nu. Okay, so in order for you to assess this yang ini, okay, yang ni dah ada dah. From M tu you boleh dapat V ni. Okay, and then D ni pun ada. So nak pakai nu ni, dan juga adalah beberapa equation lagi, Prandtl number. Okay, so that information will be evaluated at this two temperature. For water is 45, you ambil 45, properties at 45, and dekat oil you ambil properties at 80 degrees. Okay, tapi for this purpose I actually just buat untuk you lah. Okay, I think in cold water is the only thing that you need to calculate lah. Okay, the Reynolds number. Okay, this one don't have to sebenarnya because it is annulus. So the hydraulic diameter is this one. Okay, and Nu or No is basically based on D yang ni, yang ni ini. Based on ni Di bagi D naught. Okay, so don't have to determine the Reynolds number pun lah untuk ni. Okay, cumanya you kena buat interpolation je. Okay, because from this one dia punya Di bagi D naught, kan? Kalau kita tengok balik, Di bagi D naught dia adalah 0.666. Okay. 2 bahagi 3. Okay, 2 over 3 is 0.666. Dekat dalam ni tak ada 0.666 So this is in between 0.5 and 1. So you kena buat interpolation lah. Okay, kena buat interpolation. In between, you nak kena cari NUI. Okay, NUI in this case is 5.45. Okay, dia kat NUI lah. So dekat sini, kat region ni. Sekejap ya. Dia dekat region ni. Dia punya NU. So dia nak check this one is 0.6667. Yang ini X ni nak cari. So you kena buat interpolation lah. So you rujuk balik ke interpolation punya formula. Then you will get straight away and U is 5.45. Okay. Once you get NU, you will get H lah. Okay. K is being given. Okay. K is 0.637. This one K is 0.138. Okay. So D pun sama 2 dengan 3. Okay. So you get straight away lah H. So the answer will be, then dapat H tu, just gunakan this equation lah. Okay. So this will be the punya answer dia, 74.5 watt per meter square dot K. So don't forget the unit is sama macam konvektif juga unit dia, watt per meter square dot K. Okay. So this is the answer lah.